Hi, I'm Patrick Mannion, Director of Content at Claritech, and we all know how wireless testing is really difficult. Well, we're here in Curio's lab in Louisville, Colorado to talk with Bob Mayer, VP of octoScope, and Bob's going to take us through some of the ins and outs of octoBox, a key personal wireless test bed. So you all know how difficult wireless really is and wireless testing of it, right?
Yes.
So can you explain what octoScope does and how octoBox goes about testing it?
Sure. One of the challenges in testing wireless devices is testing for true over-the-air performance, but in a controlled environment so you don't have noise from outside sources affecting your test. So when you're actually doing wireless testing, there's a range of different things that you want to test for,
Right.
such as throughput, forwarding rate, packet error rate, how it can roam between access points, roam between LTE and Wi-Fi,
Right.
how it selects its channels, data rate adaptation, things along those lines. These are all the measurements that you want to take to see how well your device is performing. The things that affect that performance are the things in the right-hand column, such as range, how far away is it, its orientation, multipath, interference from adjacent channels, co-channels, other devices such as Bluetooth, microwave ovens, Zigbee. These are all the things that can affect your performance on the left-hand side. What octoBox provides is a platform to control all the variables on the right so you can assess the performance of your device on the left. In our controlled octoBox personal test bed, we can provide you the control over those so you can create a repeatable, automated, and trustable test that's fast.
How would somebody normally have done that?
They would normally go into a walk-in chamber or go to an open-air test house.
Right.
So this augments the capability of those by bringing in the ability to put the instruments inside the box while the engineers and the other test equipment are outside the box. So it's complementary. This one can sit on your desktop. It can be as large as a microwave oven up to a refrigerator and scale up even larger than that.
Would engineers have typically, doing in a real-world test environment, have multiple devices spread around like a real-world environment, like a suburb or three or four houses?
They would be looking for how well does it perform when the neighbor turns their microwave oven on,
Yes.
which is an uncontrolled
Real-world
parameter
environment type thing,
right? Yeah. So what we offer is 3 standard test beds. One's called the STACK-Benchtop, one's called the STACK-SNB, small net builder, and one's called the STACK-16. Depending upon what you want to test, will direct you towards which is the test bed that works best for you. So there's a range of different tests. If you want to test, for example, MIMO over the air, all 3 of them will support that. If you want to test throughput versus range, all three of them will support that. If you want to test multipath capabilities, that's where the SNB stands out. If you want to test mesh capabilities, that's where the SNB stands out.
Right.
If you want to test interoperability between 2 vendors' devices, that's really where the STACK-16 is going to stand out, where you've got a lot of antennas, so you're going to get lots of MIMO, you're going to get lots of redundancy. So this is our STACK-16.
Right.
This is a 2-box system connected with attenuators between each. There are 16 antennas in each box, so you can test a true 8x8 device with diversity. We control the attenuation so that you can test the ability for different devices in different boxes from either the same vendor or different vendors and see how well they perform as you're increasing range between them.
I like how the devices rotate inside. I guess that gives a good orientation. That gives a good idea of how they perform in the real world by rotating 360 degrees.
Correct. And seeing at which angle.
Control that, right?
Yeah, and that's controlled via software. It's automated. It's part of our automated scripts. You can have it continuously rotate, or you can have it rotate at increments and take throughput measurements at those increments. The antennas are movable, so you can move them inside to the positions that you'd like. So let me show what I mean.
Yep.
If we were to look at data rate versus distance or attenuation,
Right.
in short distances, you want your link in .11 AC to negotiate itself to the highest MCS,
Right.
which is modulation coding scheme. So that's where you're going to get your highest throughput. But as you add attenuation, that modulation coding scheme starts to fall apart. So if you were just to maintain that modulation coding scheme, your throughput would drop down to nothing.
Right.
So a proper device that's adapting ideally would then switch to MCS 8, and when MCS 8 starts to fail, switch to MCS 7, and follow the outside of this curve all the way down.
So all the stacks do testing for Wi-Fi, cellular, and all that, right?
Correct.
All the various options.
Correct.
And how far up the stack does it go?
Well, it goes all the way up to the TCP layer.
Right.
So we test throughput typically using iPerf. It can support all the technologies that are in the 700 megahertz to the 6 gigahertz range.
Okay.
So we can support Bluetooth, we can support Zigbee, we can support LTE, obviously Wi-Fi in both bands. Anything that falls into that frequency range, we can support.
I'm sure over time you can adapt as well as standards change and requirements change by customers. Right?
Of course.
Yeah, okay.
So in our benchtop, the STACK-Benchtop, we have several different PALs. A PAL is our intelligent device that can act as either an access point, a station, a monitor device, a packet capture, a traffic generator. I mean, it is the brains of the unit. It's what allows you to really test the capabilities of the device under test.
Okay.
While you're monitoring the air to see how that device is adapting to the impairments that you're putting in, such as interference from our iGen.
What's the octoBox server? I guess that's controlling all the PAL devices? Or?
So that is going to act as the device that controls everything,
Right.
captures the database, displays all of the charts, puts them into a PDF report or a file for all of your data. It also acts as an endpoint for your iPerf server.
So can you have multiple boxes located geographically anywhere in the world, dispersed anywhere?
Absolutely, as long as you can connect via IP. So this is a 26-inch box that sits right on your desktop.
Right.
It can sit in your cubicle. It does not have to be shielded, does not have to be in a anechoic chamber. It can be out, in a typical cube for an engineer.
And I guess if you want to go to a mesh test bed, you'd have multiple of those distributed around the facility, right?
That's where you come into what we call our Stack Small Net Builder. So this acts as your mesh. So you've got 4 different boxes that are all interconnected via a mesh network.
Okay.
And then through attenuation, you can control devices that are connected in and which device they should be attached to, associated with, and roaming from box to box, or even roaming outside of the box to an LTE network.
Gotcha, okay.
So you can test your ability for your mesh to react to the devices that you're controlling with regards to attenuation between what is emulating as rooms.
Right. So as the signal decreases for each node, I guess, right? Then it'll switch over accordingly as well. You can control the switching back and forth.
And that's so you control the environment in which it should switch.
Right.
And you're testing the ability for that device to make an intelligent decision to make the switch.
Decisions on roaming, et cetera.
Right. So
Gotcha, yeah.
device manufacturers can actually test their algorithms as to when they should be making a good decision to roam.
Really optimize the algorithm for that, right?
Yep. And they can do it in a controlled manner that's repeatable, fast, and reliable, so they can adapt those algorithms more quickly, get through the development process more quickly, and get their products to market faster.
So how flexible is the system?
It's very flexible. We do have some standard configurations, so we call them the standard benchtop, the standard SNB, the standard STACK-16.
Right.
But they're made up of components, so you can see the individual octoboxes of different sizes. It's scalable,
Right.
so it can become a large room, could be a large house. They're interconnected with RF cables. Everything is shielded, so everything inside is completely controlled.
Gotcha.
We connect them with splitters and combiners, with PALs that are acting as the access points, stations, traffic generators, packet captures, monitors. We have attenuators that allow you to increase the seaming distance between each of the different boxes. And we have the iGen that can generate interference and send that interference into whatever box it's connected to, or through splitters and combiners to other boxes as well. These meet most of our customers' needs,
Right.
but we have several customers that have said, my environment is close but a little bit different than this. Is there a way that we can configure it specific to my environment? And the answer is absolutely yes.
Right. Okay. Great. Thanks, Bob.
Sure.
Is that it? Good
Nope,
job.
that's it.
Appreciate your time.
Thank you.
Nice.